Hi everyone, I am Abhinav Bansal and today I am going to present before you my learnings on the topic of mathematical thinking and how not to be wrong. The sources that I have referred to are Introduction to Mathematical Thinking on Coursera and How Not to Be Wrong by Jordan Ellenberg. Whenever we hear the word math, the first question that comes to our mind that why God, why? And we often ask that what was the use of all that tough mathematical differential equations, calculus integration and those tough geometrical problems that we studied in our schools. And moreover, there was always an estranged x that we could never even find, right? So obviously I will not go into this, but the least I can assure you is that you will not feel the same after watching this video. Apart from why, let's just briefly deal with what and how. Mathematicians like to boast that maths is a science of not being wrong about things. But in a less abstract sense, we can say that mathematical approach is a formalized version of our natural mental reckonings, an extension of common sense by other means. So this formalized version of our natural mental reckonings and extension of common sense. What do these terms actually mean? Let's look into a problem to understand these. Suppose this is a plane and it is having bullet holes in it in the form of these red marks. And suppose you are an engineer and you are asked that you have to recommend some kind of the most vulnerable part in this plane where some kind of armor can be fit so that the vulnerability of the plane gets reduced. But while doing this, you have to make it sure that the mass of the plane doesn't rise too much because of the armor, that it can't even fly. So what you do is you count the number of bullet holes per unit area on these different parts. Suppose, let's say, the number of bullet holes per unit area in these wings is 0.7 and number of bullet holes per unit area in this body part is 0.8 and in here it is 0.6. So if you are a normal mathematician, then you will say that okay, and do the armoring on this body part where we have found the maximum number of bullet holes per unit area. Okay, but if you do this, you are not undertaking a mathematical approach. Why? Because you haven't, while doing this, you have assumed that the bullets are not even hitting, these engines. There are no bullet holes on these engines, so you have assumed that no bullet is hitting these engines. But if you are a true mathematician, you have to question your assumption that why bullet is not hitting these engines. So you can either say that engines are invulnerable and bullet cannot even reach, but this is illogical. So you have to assume that when the bullet hits these engines, then a plane is going down. So the armoring should be done not on this body part but on these engines, because all the planes that have got hit on these engines have not even returned. So these are the most vulnerable parts, not the body part. Okay. Now let's jump on to another aspect of mathematical thinking, which is non-linear thinking. We humans have a natural tendency to think in a linear pattern, be it globalization, be it materialism. Like you may think that best of the mobiles, best of the laptops and best of everything will make you more happy. So what you are doing like this is you are thinking in a linear pattern that as you go up and up, as you attain more and more, your happiness increases or your satisfaction or whatever it is. You tend to think in a linear way, but actually reality is often represented not by a linear curve but a Lefferts curve. You must have seen this. There is tax revenue on y-axis and tax rate on x-axis, and there is some optimum point where after which if you increase the tax rate, revenue is going to come down. And there is one more example in ethics that you must have seen, that here we have on x-axis we have fear, and on y-axis we have some kind of persuasion or whatever you want to do. Okay, this graph is also like this. To a point, if you increase the fear in some person, he is more likely to obey your orders. But after some point, if you increase the fear further, the persuasion is not going to increase, but it will decrease, because the person will develop some kind of great dislike for you, and he will try to, stop you rather than obey to you. Similarly, in UPSC, what we have seen in aspirants, we have seen that they tend to think that language, if they improve their language, they are going to score better in mains, and they, tend to use very flowery language in their essays and all. But what it does, if your language is, weak, then you can say that your marks will increase up to a certain level as you go on increasing your language. But after a certain level, if you further increase your language after this, then your marks will come down, because examiner will find it tough, to check your copy. So most of the reality is often represented by Lefferts curve. So by nonlinear thinking, we can say it means that which way you should go depends on where you already are. Let's say that in US they always say that more of capitalism is good and less of socialism is good. So let's say this y-axis has prosperity, and on x-axis we have capitalism. Okay, and we will see that as US has opted for more and more capitalism, it may have given more prosperity to its people initially, but after a point it may have gone down, and we may find USA on this point as of today, and we may have Sweden, which is having less of capitalism but more of state sponsored or socialistic policies, which is having more or less similar or even more prosperity than of USA. So we can say that which way you should go depends on where you already are. If you are on this side of the curve, then probably you should have less of capitalism and adopt more of socialistic policies. And if you are more on this side of curve, you can afford to have more capitalism so that you can attain this maximum level of prosperity. Next in line, we have this principle of exhaustion. What it means is that if universe hands you a hard problem, try to solve an easier one instead, and hope that the simple version is close enough to the original problem that the universe doesn't object. I'll give you an example for this. Earlier, when we didn't know that how to find the area of a circle, what we did? We made a square inside the circle because we knew how to find the area of any polygon. So we found the area of this square inside the circle, and we also made a square outside the circle, and we found that the area of the smaller square is 2 and the area of the bigger square is 4. So the area of circle must lie in between 2 to 4. Okay, and now they also knew how to find the area of a 16-sided polygon. So they found the area, and they found that the area of the circle should lie between 3.06 and 3.18. This is when the radius is 1 and the area of circle is actually pi r square, which means pi into 1 square is equal to pi. A method similar to method of exhaustion is method of negation. Negation is, in simple words, is nothing but the opposite statement. Okay, so to give you an example that how method of negation works, we have this problem with us where you have to prove that root of 2 is irrational. In order to prove this, under method of negation, what we do is that we take the negation of this, that is the opposite statement of this statement, and we try to prove that wrong in order to prove it right. I hope you are following me. So let's go step by step. This is the statement that we have to prove, which is root of 2 is irrational. So the negation of this statement would be root of 2 is rational, right? So if we prove that this is false, then automatically we will be proving that this is true. Okay, so to prove this, we assume that root of 2 is rational. Then if it is rational, then under root 2 can be written as p by q, where p and q do not have any common factors. By squaring both sides, we get 2 is equals to p square by q square. Q can be taken on this side, then p square is equals to 2q square. Okay. From this we can say that p square is equals to 2q square. What this 2 is making, this is making the p even number. Okay, because p and q are rational numbers, and anything multiplied by an even number becomes an even number. Therefore p square is even, and p is also even, because even into even is equals to even. Odd into odd is equals to odd. Therefore p is even. If p is even, then p can be written as 2n also. 2n square is equals to 2q square. It will become 4, and we can write it like q square is equals to 2n square. Similarly, q is also even. If p and q both are even, then this statement doesn't hold true, because earlier we had assumed that p and q do not have any common factors. That's why this is false. If this is false, this is true. This is how method of negation works. If at this point of time you are wondering that why I'm doing all these derivations, I just want to let you know that there is a reason behind it, and you will soon get to know it. So what are the practical uses of this method of negation applications? I can say we can use it as part of answer writing. Suppose you have got a weird essay topic like pen is mightier than sword. Okay, then how you can think, you can take the help of method of negation. You can think the otherwise, like sword is mightier than pen, and then you can derive some necessary conditions for why pen or how pen can be mightier than sword. Like we need a properly functioning democracy, press freedom, right? And then for pen to be mightier than sword, we need literacy. So this kind of brainstorming can be done by using this method of negation. And apart from this, we have also seen lawyers to be using this method of negation. Like suppose if a person is on death trial and there is a witness who is testifying against him, and for his lawyer to defend the accused, the lawyer doesn't have to prove the witness, whatever he is saying is wrong. He can just prove that the witness is not credible. Okay, we now come to game of probability. It is one of the most interesting topics in maths according to me. Yeah, so now before looking at this, I want you to first of all answer my question. Suppose you and me are playing, we are tossing a coin, and we have done it 9 times, and for the last 9 times I have been choosing, and I have chosen all 9 times heads. Okay, and fortunately for all the 9 times I have also won, meaning the coin has given heads consecutively for last 9 times. Okay, now suppose for the 10th time I have given you a chance to choose between heads and tails. So I want to ask you, what would be the mental thinking behind your choice. You might like to think like that. Maybe the coin is biased, right? Because it has given consecutively heads for the last 9 times. Maybe the coin is biased. Maybe there is something wrong with the coin, and now maybe you should choose heads. This might be one of the assumptions in your mind, but we both know that the coin is normal, and I am even ready to exchange the coin if you want. Okay, so this assumption is wrong. So coin is obviously not biased. Now you are only left with one assumption, that since heads has come for the last 9 times, there is a possibility that you might think tails hasn't come for last 9 times. There might be a greater chance of tails to come now, so you might be inclined to choose tails for the 10th time, isn't it? But if you are thinking like that, it's not a mathematical way of thinking, and I'm sorry to say, you are wrong. Now let's look at this. This shows that when the number of flips which are denoted on the x-axis, when the number of flips are less, the divergence, this is the divergence from the mean value is 50%, that is 50% probability of heads and tails. The divergence from mean value is more when the flips are less, but as the flips go on increasing, this divergence decreases. It is pretty obvious. Just think that you have tossed 10 coins 10 times, okay, and you have tossed the same coin 1000 times. What is the probability that divergence, say 8 heads and 2 tails, and 800 heads and 200 tails? Which do you think is more likely? Obviously this, right? So divergence is more when flips are less. This is what happening here, and this is what happens during or while we check the efficacy of some medicine. That's why we say that we have to increase the sample size so that we can fairly check the safety levels of any medicine. Okay, and in lottery, here is a simple example of lottery also. Suppose in a lottery on one day you get somebody gets a number of 123. So the probability of getting 123 number on the second day is also the same. You may like to think that probability of the same number coming on 2 consecutive days is obviously less, but if you take this day as an individual entity, then if you find the probability of this number, it is the same. So if on 2 consecutive days the same number comes, you are not expected to reach to the manager of the lottery and abuse him. You have to have mathematical thinking. Okay, this observation can aptly be explained by this law of large number, that is when the probability has a large sample size. It works, or the probability works, not by balancing out what has already happened, but by diluting what has already happened with the new data. Okay, so what has already happened doesn't matter. What is going to happen for next, at the next instance, is going to dilute what was the bias that has already happened. This is the true essence of these lines. Okay, now we move on further. Now let's try to apply this concept of probability in our day-to-day life, or the exam that concerns us all, that is prelims. Now suppose you are in a situation where you have attempted 60 questions and you are getting 120 marks for sure, that and you are also sure that cutoff is going to be less than 120, say 190. Okay, so if you are in this situation, tell me, if there are 3 questions in front of you in which you know that two of the options are surely false and right answer lies between other two options, and there are total 3 questions like this. Would you try to attempt these 3 questions as well, having said that you already know about your present situation? I think if you are sensible enough, then you will not attempt these questions. But let's just assume now that for IFOS interview, mains, you need 130 marks, and you also know that in 10 questions 2 of the options are wrong and the correct answer lies in other 2 options. Then probably you are willing to take a risk. Or even if this exam is not there, then also you can take a risk in this case, but not in this case. Right? This is simply the law of large numbers that we had studied earlier. Now, if you want to be a godman or a stockbroker, but you don't know nothing, don't worry, I have a mathematical solution for you. Why? Because universe is large and improbable things happen a lot. Yeah, here it is. First of all, let us look into this Baltimore stockbroker problem. Suppose there was a stockbroker who knew nothing about his business. All he did was he chose a big group of people. He divided this big group of people into 2 halves, and there are 2 options in stockbroking. In one you can lose and another you can gain. Suppose to the first half he asked to choose option A, and to another half he asked to choose option B. It is sure that in one of these choices, one will gain and another will lose. So suppose B has gained, then he took these number of people in B, he again divided them into half, asked them to choose option A or choose option B. Suppose now A won. Now he again took these number of people, he divided into 2 and again asked them to choose between A and B. So after a series of these steps, he is left with 10 people. After 10 steps, he is left with 10 people who followed exactly what the stockbroker asked them to do. So these 10 people will be preaching this stockbroker like anything. They will join his fan club. They will be boasting about his the stockbroker ability or capability or knowledge to everyone else, and these are the people that will make him successful, because these are his advertisement agency kind of thing. Yeah, now we move on to Godwin. This was the stockbroker problem. Godwin is also a similar thing. Godwin also do something like this Baltimore stockbroker did. They take a large group of people, say 10,000. Okay, they ask some people to do some things and ask other people to do some other things. These things might work from them and might not work for them. They may ask them to do some other things, A, B, C, D and all that. After a series of steps, he will be left with some group of preachers who have followed him blindly and who have gained a lot because of the arbitrary decisions taken by this Godwin. So this is how this Godwin business works. You know what is common in both these things, the stockbroker and the Godwin? In both these cases, we didn't know what was the total sample size or the hidden data. If this hidden data was available to us, then probably we would have made an informed decision. But since this data was missing and we were exposed only to this data, therefore our conclusions were made, but these conclusions were incorrect. Another fascinating thing that I find in maths is that there can be a number of solutions that are possible for a given problem, and therefore we should think before we jump to anything. Now before I get into it, I want to test your speed. You have 10 seconds to do. Question is on your screens. Find if 569401 divided by 2708 as an integer quotient or a zero remainder. Okay. Now, yeah. So if you are doing it like this, 569401 2708, and you are trying to do all these things, then I would suggest you to go back where I was deriving this solution. Root 2 is irrational. There I told you that I am doing the derivation because I am going to use it in the next slides, and now I am gonna use it. See, in that problem I told you that any number, here we were at this place, I told you that any number, if it is multiplied by an even number, this whole becomes even. Now see this. This is even and this is odd. 569401 divided by 2708. If we multiply this with any number, say n, it will always be even. It will never be odd. Okay, so it will never have integer quotient. So before going to this, you should have thought like that. I will also give you a personal example. Once I was given a problem like this, that this is a metallic wire, and suppose some flux is going through this wire, electrical flux or somewhat like that, but there was a catch that there is a cavity in this wire. This is a metallic wire, this whole thing, and there is a cavity, this cavity in this wire. Okay, and now we have to find the resultant flux. Okay, now what I did, I was new to calculus and I was pretty enthusiastic of using it, so I just used integration r dot dr pi r square plus this and that. Okay, you get it. And but still I was not able to get to my answer because obviously it was very difficult to break this into so many parts. This is a circle and this is a cylinder also. So by this method it was pretty difficult and I could not think of any other method because I was too much focused on solving through this method. I was pretty sure that if I invest more time then I am going to get a solution, but eventually I didn't. The next day when I went to my coaching in Kota, this was in Kota, so our teacher gave us a solution. He told us that this is a wire, suppose there is no cavity, and find the flux with the simple formulas that you usually find. Now suppose this cavity is having an opposite flux, and since this cavity is also like a cylindrical wire, so we can also find the flux through this with normal formulas, and since these are vector quantities, by adding these two we will get a solution. I was like, what the hell? This is the most easy solution that we could find, that we can get. This is the most easiest solution, and this was the most difficult one, which I was so adamant on investing more and more time. So what is the moral of the story? The moral of the story is that there is a hard way of doing things and there is also a smart way of doing things. Mathematicians or mathematical thinking should encourage us to follow the smart way, not the hard way. Right? Even some of us may have an inclination towards enjoying the problems in a hard way, and it is good to do what you want to do, but sometimes you ought to do what you need to do. So these are the core messages that I got from the book and the course. I hope you will find them useful in one way or another. Thank you and have a nice day.